Okay, AP Chemistry, let's do some gas density practice problems. A problem might read, the density of an unknown gas is 2.12 grams per liter at 22 degrees Celsius in 1.1 atmospheres. What is the molar mass? So I'm going to read through the problem and say that the density is given to us, and that's going to be 2.12 grams per liter. At a temperature of 22 degrees Celsius and a pressure of 1.16 atmospheres. Now, it didn't tell us that 1.16 atmospheres is a pressure, so you have to know that atmospheres is a unit of pressure. So if they're giving you atmospheres, they're talking about pressure. My density has liters on the bottom, so I'm good. Temperature can't be in Celsius, it has to be in Kelvin. So in order to turn Celsius to Kelvin, I simply add 273. And pressure's already in atmospheres, so we're all good. R is always 0.08206 liters in atmospheres on the top, moles in K on the bottom, and they're asking us to find the molar mass. So remember our molar mass kitty formula, derived from the ideal gas law. I derived it for you in another video. So we're going to say molar mass. The molar mass kitty is a good kitty because he puts dirt, density, ideal gas law times temperature over P. Now I'm going to put 2.12. First I'm doing density. Grams on the top. Liters on the bottom. 0.08206 liters atmospheres over moles K, because R is on the top. Temperature also goes on the top of 295 K, and pressure goes on the bottom. So it's 1.16 atmospheres. Let's check our units. Atmospheres cancels, K cancels, liters cancel, and I'm left with grams per mole as my unit for my answer. And grams per mole is an adequate unit for molar mass. Remember, molar mass is what we read off the periodic table of the elements, and it is always in grams per 1 mole. So in my calculator, I multiply across the top and then divide by the bottom. And then I get an answer of, let's see how many sig figs in my problem. I had 3 sig figs in my problem as it was given to me. So answer in 3 sig figs, and that's 44.2 grams per mole. Now I could look at a list of gases and I could figure out what the possible identities for this were. There's also other ways you can figure out the identity, and that's through the empirical molecular formula using a spectrophotometer. All right, let's do another problem. We'll solve for something else. Let's solve for density. What is the density of an unknown gas at STP if its molar mass is 47.6 grams per mole? So density this time is what we are solving for. It's at STP, so the letters STP stand for standard temperature and pressure. That gives us the temperature and the pressure. Standard temperature is 273 K. Standard pressure is 1 atmosphere. And it also gave us the molar mass of 47.6 grams per mole. and R is always the same. So we're going to use our molar mass kitty. I'm going to rearrange the molar mass kitty formula for you. So dRT over P. And I'm going to rearrange this so we get density by itself. We'll get P off the bottom. And then we'll get density by itself by moving R and T to the other side. So in this case, D equals P times the molar mass over RT. Let's start plugging in now. I'm going to put the pressure on the top of 1 atmosphere. I always use my units when I'm doing this so that I make sure that I'm not making mistakes. And my units tell me whether I'm making a mistake, because if they don't cancel out right, then you're making a mistake. Next is my molar mass on the top, so 47.6 grams per mole. Let's watch what I do with R now, because R is on the bottom. So I need to flip it. The number goes with liters and atmospheres. 0.08206 liters atmospheres and moles K. So I just put R on the bottom, or I flipped it, and then T also goes on the bottom. Doesn't matter where you put it. You could put it here, you could put it here, of 273, like such. So K cancels, moles cancel, atmospheres cancel, and I'm left with units of grams on the top and liters on the bottom. This is important because it's not grams per milliliter. It is grams per liter. So let's multiply across the top and divide by the bottom. Now, let's not make a careless mistake, because you can't type into your calculator 47.6 divided by 273 times 0.08206. You have to use parentheses on the bottom. If you have a simplistic calculator and you're not sure, you could also multiply across the top, then divide by the bottom, and then retype into divide. So 47.6 divided by 22.40,238 gives me a final answer of 2.12. 3 sig figs is what I was given, grams per liter, and that's the answer for the density. All right, let's do one last one. The last one says, what is the density of CO2 at STP? Now, this might be confusing because you're going to look at this and be like, well, they didn't give us any numbers. How do I know what's my given, and so on and so forth? And so we have to read between the lines. Density is what they're asking us to solve for. And STP is actually some variables. STP tells us the temperature is 273 and the pressure is 1 atmosphere. Now, just a heads up, when they give you things like STP, that's reference numbers, you can consider those to have unlimited significant figures because reference materials are considered to be exact. we can always consider R to be given. And also, we have CO2, so we can use our periodic table of the elements to add 1 carbon at 12.01 and 2 oxygens at 16 apiece to get 44.01 grams per mole. So let's remember, we rearrange for density. Density equals molar mass times pressure over RT. So 44.01 goes on the top. That's grams per mole. Pressure goes on the top. R goes in the bottom, so 0.08206 liters in atmospheres are on the bottom. And that moves moles and K up to the top. And then on the bottom is also temperature. Doesn't matter where you put it. So K cancels, atmospheres cancel. Remember, you got to make sure there's 1 on the top and 1 on the bottom to cancel them. And then you will get units of grams per liter, which is good for a density. Multiply by the top and divide by the bottom to get 1.965 grams per liter. I'm using 4 sig figs simply because I used my periodic table of the elements, and my periodic table of the elements happen to have 4 significant figures. So there's a couple examples for you to help you get started with the density practice problems.